Okay, ladies and gentlemen, lesson 2.1 continues. This is 2.1 part 3. There are a lot of very important skills in this section, so we need to go through them fairly carefully. Here's a function. You're given a picture of it rather than the rule. So here's the function y equals f of x. Now, first thing you're asked to do is find f of 0. We can see that according to this answer sheet it should be -2, but let's see how we get that. F of 0. 0 is the input. That's an x value. So what I do when I'm asked to find f of 0 is I first find 0 on the x-axis. And then what I do to find f of 0 by using a graph is I either look up or down, because remember my y value is my output, and to find y you either move up or down on graph paper. Well, obviously I hope you see that you would have to move down in order to find the line. And when you're touching the graph, notice what y value you're at, -2. Therefore f of 0 is -2. Let's practice some more. Find f of 2. 2 is an x value. So you go to your x-axis and you stand on top of 2. Now what you're normally supposed to do is look up or down until you find the graph and then touch it. Well, notice we're already standing on the graph, right? We didn't have to move up or down at all. And right where we're standing, the y value is 0. Anytime you're on the x-axis, the y value is 0. So f of 2 equals 0. Suppose I want to find f of 4. Let's practice this. F of 4. 4 is an x value. It's an input value. So you go to the x-axis and you find the number 4. Now notice that this time your line is above you. So you walk up and you hit the line. Notice where you're hitting the line, the y value is 2. Therefore, f of 4 is 2. Last question, same concept. F of -4. -4 is an input value, which means it's x. So I put -4, I find -4 on the x-axis. And notice this time to find the line or to find my graph I need to move down. And when I move down I hit it at the -6 level. Therefore f of -4 is -6. So what you need to remember when you're reading from a graph is the number that you're putting into the function is x. The number that you're getting out of the function is y. Always. Domain goes in, which is x. Range comes out. Okay, here's a chart. We're told that the top row of this chart represents x values. Those are called inputs. And the bottom row of this chart represents f of x, which is really another way to say y. Those represent outputs. So if you're reading this chart correctly, if you put in a -10, you get out 23. If you put in a -5, you get out 96, and so on. So when I say find f of -5, -5 is an x value. When I put in -5, I get out 96. Therefore, f of -5 is 96. That's my answer. Input -5 to get an output of 96. Now, if f of x is 23, find the value or values of x that cause that. Well, this time they're telling me to look at f of x. So they're telling me to look in the bottom row. When I look in the bottom row, I see the number 23 twice. One time it was caused by putting in a -10. The other time it was caused by putting in a +10. So how many x values correspond to an output of the number 23? There's actually two answers. -10 is one answer, +10 is the other. So don't get excited just because you see it the first time. look through the whole row. Okay? Now, this question gives me a picture of a parabola. You can assume that these, I'm trying to do this very much like your course compass homework does. A parabola doesn't stop. So there's basically arrows up here indicating this graph goes on forever. All right, first question asks you to find the domain of this parabola. Now, what domain means? Domain is x. And on graph paper, okay, let me kind of help you visually. On graph paper, anytime you're finding the x value, you're scanning from left to right. Okay? Now, okay, let's start over. Remember, in this particular problem, when the parabola opens up, not only does it go up, but notice the branches of the parabola get wider and wider and wider, right? They never stop. So you are going forever from left to right. That's why the domain is all real numbers. It never stops. Range refers to the y value. And whenever you're measuring range, you're going from bottom to top. Well, notice the bottom number here is -4, correct? The lowest point occurs when y is -4, and then the graph keeps going up. That's why your range would be all y values greater than or equal to -4. It could equal -4 because the elevator stops there. The elevator also goes up. Last question. Does this graph represent a function? The way you determine if a picture of a relation is a function is by applying the vertical line test. And the way the vertical line test works is you take your graph and you draw an imaginary vertical line through the graph. Any vertical line you draw is allowed to cross the graph one time. If it crosses more than one, then your graph is not functioning properly. So, notice in this particular parabola, any vertical line you imagine, take a piece of paper, take a pencil and draw a vertical line through that parabola. It only touches it one time. Therefore, it passes the vertical line test, so it is a function. Okay, let's do one more example. All right, suppose I have this shape, which basically in math is called an ellipse. It's a flattened circle. All right, if I want to know the domain, remember domain means x, so I'm scanning from left to right. My left value starts at -1, and it stops at +3. That's why the domain x is all numbers in between -1 and +3. X is sandwiched in between -1 and +3. Whenever you have a sandwich, these signs should point to the left. All right, because it basically says x is greater than or equal to -1, but at the same time, it's less than or equal to 3. My range. Remember, range is my y value. To find the range, you scan from bottom to top. Well, at the very bottom of the graph, my y value is 0. Now, don't pay attention to the fact that x is 1. I'm looking for range. My y value is 0. As I scan up, my y value stops at 4. Therefore, my y value would be all numbers in between 0 and 4, inclusive. And what I mean by that is it equals 0 and it equals 4. Does this graph represent a function? And the reason the answer is no. From the last example, remember what we talked about. In order to determine if a picture represents a function, you apply the vertical line test. If I draw a vertical line down through this ellipse, it crosses the graph more than once. That implies that we do not have a function. For a function to work, for a relation to be a function, an x value can only match one unique y value. So in this case, you're running into a problem when you have an x value that's basically assigning itself to two different y values. That cannot happen. Another way to remember it, please, to apply the vertical line test, you draw vertical lines through a picture. If a vertical line touches a picture only one time, it is functioning. If it touches more than once, it is not functioning. Okay?